What if, right now, nothing in the universe is actually pulling you down? It feels impossible. You can feel your weight pressing against the chair or the ground beneath your feet. Every moment of your life seems to confirm the same simple truth, that gravity is a force constantly pulling everything toward Earth. But what if that feeling is misleading? What if gravity, the thing we trust to explain falling apples, orbiting planets, and even the motion of galaxies, isn't a force at all? And more than that, what if nothing is ever truly being pulled? Tonight, we begin a quiet journey into one of the deepest mysteries of reality. A mystery that reshapes something so familiar, so constant, that we almost never question it. Gravity. If you've watched our earlier Valoran video about black holes bending time itself, you may remember how reality begins to feel less solid the deeper we look. And gravity is where that feeling truly begins. Because somewhere between what we were taught and what the universe actually does, there is a gap. A gap filled with curved space, distorted time, and paths that don't behave the way we expect. Here, falling is not what it seems, and stillness may not be still at all. Before we drift deeper into this mystery, take a quiet moment to support the channel. If you enjoy these slow cosmic explorations, consider subscribing, liking the video, and turning on the bell so you don't miss future journeys. You can also join as a member if you'd like to support even more. And as you settle in, let me know where in the world you're listening from tonight. If gravity is not a force, then something else must be guiding everything that moves. Something quiet, invisible, and always present. To understand it, we need to slowly shift the way we imagine reality itself, not as a stage where objects move, but as something that shapes their motion from within. Imagine for a moment that space is not empty, not a void, but something with structure, something that can stretch, bend, and respond. And time, not separate, not ticking somewhere in the background, but woven together with space into a single continuous fabric. This is what Einstein revealed. Space and time are not independent things. They are part of the same entity, a four-dimensional continuum we call spacetime. You are always moving through it, even now, even while sitting still. Because being still in space does not mean being still in spacetime. Time continues, and so your path continues with it. Now here is where the quiet shift begins. If space-time is something real, something with structure, then it can also be affected, can change. And what changes it is mass and energy. Every object, from a tiny grain of dust to a massive star, subtly reshapes the space-time around it. Not by pulling on things, but by altering the geometry itself. The heavier the object, the deeper this change becomes. But this change is not like a dent in a surface. It is more subtle. It is a change in how distances and directions behave. A change in what counts as a straight path. Because in curved spacetime, straight lines no longer look straight. They become something called natural paths or geodesics. And everything in the universe follows these paths, not because they are forced to, but because there is no other way to move. Imagine walking across a perfectly flat field. The shortest path between 2 points is a straight line. Simple, predictable. But now imagine that field is gently curved, like the surface of a vast sphere. The shortest path is no longer what looks straight to your eyes. It bends subtly, following the shape of the surface itself. You are still walking straight, but the world beneath you is curved. This is the key. Objects are not being pulled. They are simply moving along the straightest possible paths in a curved reality. When you drop something, it is not being dragged downward by a force. It is following its natural path through spacetime, a path that happens to lead toward the center of Earth because Earth has shaped the spacetime around it. And suddenly, something familiar begins to feel different. Falling is no longer an action caused by a force. It is the absence of resistance. It is what happens when nothing is stopping you from following your natural path. This is why astronauts float in orbit. Not because gravity has disappeared, but because nothing is pushing them away from their path. They are falling endlessly, freely, silently. The station around them is falling too, perfectly matched, so everything appears weightless. And here, a quiet realization emerges. What you feel as weight is not gravity pulling you down. It is the ground pushing you up. The surface beneath you is preventing you from following your natural path through spacetime. It is resisting your fall. And that resistance is what you feel. If the ground vanished, you would not feel a sudden pull. You would feel nothing at all. Just motion. Just drifting along the path that was always there, waiting. This idea is deeply counterintuitive. It reverses something we have believed since childhood. That stillness is natural, and falling needs an explanation. But in this view, it is the opposite. Falling is natural. Stillness requires a force. And this leads to one of the most beautiful and unsettling ideas in physics, that inside a small, enclosed space, you cannot tell the difference between gravity and acceleration. If you were inside a sealed elevator, far out in empty space, and the elevator began accelerating upward, you would feel pressed to the floor. It would feel exactly like gravity. And if that elevator were instead falling freely toward a planet, you would float just like in orbit. No experiment inside could tell you which situation you were in. Gravity and acceleration become indistinguishable. And so the mystery deepens. If what we feel is not gravity itself, but resistance to motion, then what is truly shaping these paths? What is this fabric made of that everything follows without question? As we continue, we will move closer to the edges of this idea, where space-time bends so strongly that even light cannot escape, and where time itself begins to slow. But for now, just let this settle gently into your thoughts. You are not being held down. You are being guided along a path written into the very shape of reality itself. Now that the idea has begun to settle, that falling is not caused by a force, but by the shape of spacetime itself, we can move a little deeper, more slowly, into what that truly means. Because if everything follows these natural paths, these invisible routes written into the fabric of reality, then motion itself becomes something different. Not something pushed or pulled, but something guided. And this guidance does not feel like guidance at all. It feels like normal movement, like doing nothing special, like simply continuing. Imagine drifting in complete darkness, with no reference points, no sense of up or down, no ground beneath you. In that state, you would feel no weight, no pressure, no indication that anything is acting on you. And yet, you would still be moving, following a path through space-time, even if you could not perceive it. This is the quiet truth of motion. You do not need a force to move. You only need a path. Forces, in this deeper view, are what interrupt those paths. They are what push you away from your natural motion. When you sit in a chair, your body is trying to follow a path inward, toward the center of Earth. But the chair prevents that. The atoms in the chair resist compression, pushing back against you through electromagnetic interactions. And that resistance is what you interpret as weight. So weight is not something being applied to you. It is something being prevented, a kind of interruption. And this leads to a subtle but powerful shift in perspective. The natural state of motion is not rest. It is freefall. Rest, the feeling of being still, is actually a state of constant resistance, where something is always pushing against your natural path. And if that resistance disappears, so does the sensation of weight. This is why, in orbit, astronauts appear to float so effortlessly. They are not beyond gravity. In fact, gravity is still very strong at the altitude of the space station. But nothing is resisting their motion. They, along with the station, are continuously falling around Earth, tracing a curved path that never reaches the ground. A perpetual fall that becomes an orbit. And here, something even more fascinating begins to emerge. If all objects follow these natural paths, regardless of their mass, then it explains something that once seemed mysterious. Why do all objects fall at the same rate? Why does a heavy object and a light object accelerate equally in a vacuum? In the older view, this required a delicate balance between force and mass, something that seemed almost coincidental. But in this new view, there is no coincidence. All objects are simply following the same geometry. The same spacetime curvature applies equally, regardless of what is moving through it. A feather and a hammer do not fall together because forces cancel out perfectly. They fall together because they are both tracing the same path through a curved reality. And so, the mystery shifts again. If everything moves according to this curvature, then understanding gravity becomes a question of understanding geometry. Not forces, not invisible pulls, but the shape of spacetime itself. And this shape is not static. It changes constantly, dynamically, responding to the presence of mass and energy. The universe becomes something alive with structure, where every object contributes to the overall curvature, and every movement is influenced by the combined geometry of everything else. You are not just in the universe. You are participating in its shape. Even your own body, small as it is compared to planets and stars, slightly alters the spacetime around you. The effect is incredibly tiny, far too small to notice, but it is real. Every atom contributes. Every piece of energy plays a role. And this leads us to a deeper question, one that begins to echo quietly in the background. If spacetime can curve, what exactly is it? What kind of thing can bend without being made of something familiar? It is not a substance in the usual sense. You cannot touch it, cannot see it directly, and yet its effects are everywhere. It determines how objects move, how light travels, how time itself flows. Because yes, time is also part of this curvature. Not just space, but time is affected. The stronger the curvature, the more time itself begins to shift. But that is a mystery we will approach gently later. For now, remain with this idea that everything you see, everything you feel, every motion you observe is the result of paths through a curved spacetime. Not forces pulling from a distance, but geometry shaping motion from within. And somewhere in that geometry, in those unseen curves and silent paths, lies the deeper truth of gravity. A truth that becomes far more strange when the curvature grows stronger, and the paths begin to twist in ways that challenge even our imagination. As we continue drifting deeper into this idea, something subtle begins to change in how we think about direction itself. Up and down, forward and backward, even the idea of moving in a straight line. All of these begin to lose their absolute meaning. Because in a curved spacetime, direction is no longer fixed. It depends on where you are and how the fabric beneath you is shaped. What feels like a straight path in one region may gently curve in another, not because you chose to turn, but because the space you are moving through is guiding you without resistance. And this becomes especially important when we begin to think about motion on larger scales, not just falling objects near Earth, but planets, stars, and entire galaxies. A planet orbiting a star may look, from our perspective, like it is constantly being pulled inward, its path bending into an ellipse by an invisible force. But from the deeper view, the planet is doing something much simpler and much more elegant. It is moving straight, not straight in the sense of a flat line, but straight in the geometry of spacetime. It is following its natural path, a path that curves because spacetime itself is curved by the mass of the star. And so the orbit is not the result of a force constantly pulling the planet inward, but the result of the planet continuously missing the star as it falls toward it, guided by the curvature of spacetime. It is a perpetual fall, balanced by motion sideways, creating a path that loops endlessly. This idea may feel familiar, but when viewed through this lens, it becomes something quieter and more profound. The planet is not struggling against a force. It is simply following the only path available to it. And this brings us to another gentle shift in perspective. If motion is guided by spacetime, then what we call gravity is not something acting across space, but something built into space itself. There is no need for a signal traveling between objects, no invisible tether pulling them together. The geometry is already there, shaping everything at once. This removes a kind of distance from the concept of gravity. It is no longer something that reaches out. It is something that surrounds, something that defines how movement happens everywhere all the time. And yet, this raises a quiet question. If spacetime tells objects how to move, then what tells spacetime how to curve? The answer, as Einstein described it, is mass and energy. Every object contributes to the curvature, and that curvature influences every other object. It is a continuous relationship, a feedback loop where matter shapes spacetime and spacetime shapes motion. Nothing is separate. Everything participates, but this relationship is not uniform. Some regions of spacetime are only gently curved, like the space around Earth, where the effects are noticeable but not extreme. In these regions, paths are only slightly bent, and time flows almost uniformly. But in other regions, where mass becomes enormous, the curvature grows stronger, and the behavior of motion begins to change in ways that feel almost unreal. Light, which we often think of as traveling in perfectly straight lines, begins to bend. Not because it is being pulled, but because even light must follow the geometry of spacetime. And if that geometry curves, then the path of light curves with it. This phenomenon, known as gravitational lensing, reveals something extraordinary. Massive objects can act like lenses, bending the light from distant stars and galaxies, creating distorted images, arcs, or even rings of light. What we see is not just the object itself, but the path the light has taken to reach us, shaped by the curvature along the way. It is as if space-time itself is quietly sculpting the images we observe, guiding light through invisible contours. And in this, we begin to glimpse just how fundamental this geometry is. It does not only affect matter. It affects information, perception, and even the way we understand distance and direction. Because when light bends, our sense of where things are becomes less certain. The universe is no longer a simple map of positions, but a complex interplay of paths and perspectives. And still, there is something deeper waiting beneath this. Because as curvature increases, not only do paths bend, but time itself begins to shift. Clocks tick at different rates depending on where they are, how deep they are in a gravitational field. This is not a metaphor. It is not an illusion. Time itself flows differently depending on the shape of space-time. But rather than rush into that idea, let it approach slowly, like a distant wave. For now, remain with the image of a universe where everything moves along paths defined by geometry, where motion is not caused, but allowed, where falling is simply following, and where even light cannot escape the influence of curvature. Because in the next step, we will move closer to the regions where this curvature becomes so strong that the very structure of reality begins to stretch, slow, and twist in ways that challenge everything we think we know. As the idea of curved spacetime continues to unfold, we begin to approach something even more subtle, something that quietly reshapes not just motion, but the very flow of time itself. Because if space can bend, then time woven into it cannot remain unchanged. It must follow the same curvature, the same gentle distortions that guide every path in the universe. And this is where gravity reveals one of its most surprising aspects. It does not just influence where things go. It influences how time passes. Imagine two identical clocks, perfectly synchronized. One is placed on the surface of Earth, and the other is carried far above into orbit, where the pull of gravity is weaker, where space-time is less curved. If you wait and then bring those clocks back together, something unexpected happens. They no longer agree. The clock that remained closer to Earth, deeper in the curvature, will have ticked more slowly. Not by perception, not by illusion, but in reality. Less time will have passed for it. This effect is incredibly small in everyday life, far too subtle to notice without precise instruments, but it is real, measurable, and essential. In fact, systems like GPS must constantly correct for this difference. Satellites orbiting Earth experience time slightly faster than clocks on the ground, and without correction, their positioning would drift by kilometers within hours. So even in ordinary moments, when you check your phone for directions, you are relying on this quiet distortion of time, this gentle stretching and compressing caused by gravity. And this leads to a deeper realization. Time is not universal. It is not flowing at the same rate everywhere. It is shaped, just like space, by the presence of mass and energy. The stronger the curvature, the slower time moves. And as we move toward regions of stronger gravity, this effect becomes more pronounced. Near extremely massive objects, time can slow dramatically. From a distance, it may appear as though processes are freezing, stretching out, taking longer and longer. But for someone within that region, everything feels normal. Their own time flows as it always has. It is only when compared to another location that the difference becomes clear. This creates a strange and beautiful layering of reality, where different observers experience time differently, each within their own path through space-time. There is no single universal clock, no absolute timeline that applies to everything at once. Instead, there are many timelines, gently diverging depending on where and how they move through the curved fabric. And this brings us back to the idea we touched on earlier, the equivalence between gravity and acceleration. If you were inside a sealed environment, unable to see outside, you could not tell whether the force you feel is due to gravity or due to acceleration. Both create the same effect because both involve changes in how you move through space-time. This equivalence is not just a coincidence. It is a clue. It tells us that gravity is not something separate from motion, but something deeply connected to it. Something that emerges from the way space-time is structured and experienced. And this connection becomes clearer when we imagine light itself moving through this curved geometry. Light does not have mass, yet it still follows these paths. It still bends when space-time bends. This means that gravity does not act by pulling on mass alone. It shapes the entire framework through which everything travels, including light, including time, including the very signals we use to observe the universe. And so, what we call gravity is not a force acting on objects, but a property of the stage on which everything exists. A stage that is not fixed, not rigid, but dynamic, responsive, alive with structure. And yet, even with this understanding, something remains unresolved. Because while we can describe how space-time curves, how it guides motion and alters time, we still do not fully understand what space-time itself is made of. Is it continuous, smooth, infinitely divisible? A place where gravity is no longer subtle, where its effects are no longer small corrections to motion, but dominant features that shape entire regions of reality. Regions where time slows dramatically, where space stretches in ways that defy intuition, and where the very concept of direction begins to lose its usual meaning. And yet, even here, the same principle holds. Objects are not being pulled. They are following paths. The difference is that now those paths have become so curved, so tightly shaped, that they all converge. And this convergence leads us directly into one of the most fascinating and mysterious phenomena in the universe. A phenomenon that is not defined by what it pulls in, but by what cannot escape. a region where space-time itself has been curved to its limits. As we move forward, we will enter this region carefully, slowly, allowing the ideas to unfold without force, just as the universe itself unfolds its structure through quiet geometry. And in doing so, we will begin to see how the simple idea we started with, that gravity is not a force, leads naturally, inevitably, to some of the most extreme and beautiful phenomena we can imagine. As we gently cross into this next stage of our journey, the idea of curved space-time begins to intensify, not in a sudden or violent way, but in a quiet deepening, like descending into darker water where familiar shapes slowly dissolve. Until now, gravity has revealed itself as subtle, guiding motion through gentle curvature, shaping orbits, bending light, and stretching time just enough to notice with careful instruments. But what happens when this curvature no longer remains gentle? What happens when space-time is bent so strongly that its structure begins to dominate everything within it? To approach this, imagine once again the paths we have been following, those natural routes through space-time that everything obeys without resistance. Near Earth, these paths are only slightly curved, leading objects downward in what we perceive as falling. Around a star, they bend more deeply, creating the looping motion of orbits. But if the mass becomes large enough, if enough matter is compressed into a small enough region, these paths begin to change more dramatically. They tilt inward, more steeply, more insistently, until something remarkable happens. The set of all possible paths that lead outward begins to disappear. Not because something is blocking them, not because a force is holding objects back, but because the geometry itself no longer includes those paths. This is the threshold where we begin to encounter what we call a black hole, though the name itself only hints at what is really happening. A black hole is not simply an object that pulls things in. It is a region of space-time where the curvature has become so extreme that all natural paths lead inward. Even light, which normally moves freely in all directions, finds no path that escapes. And this is a crucial distinction. Light is not being dragged back. It is following the only paths available, and those paths all curve inward. The boundary of this region is known as the event horizon, but it is not a surface in the traditional sense. It is not something you could touch or see directly. It is a boundary defined by geometry, the point beyond which no outward path exists. From the outside, it appears as a dark edge, a silent threshold. But from within, nothing special is felt at that exact boundary. Crossing it does not involve a sudden force or impact. Instead, it is simply the moment when all possible futures begin to point in the same direction. And that direction is inward. This idea can feel difficult to hold, because it challenges our instinct to think in terms of forces and barriers. But here, once again, the same principle applies. Objects are not being pulled across the event horizon. They are following paths, and those paths have changed. Now, something even more intriguing begins to happen as we consider how this looks from different perspectives. If you were watching someone approach a black hole from a safe distance, you would notice something strange. As they get closer to the event horizon, their motion appears to slow down. Their movements stretch, becoming more gradual, more delayed. The light they emit becomes dimmer, shifting toward longer wavelengths, fading into darkness. From your point of view, they never quite seem to cross the boundary. They linger there, frozen in time, gradually disappearing. But this is not what they experience. For the person falling, time continues as normal. They cross the boundary without noticing anything unusual at that exact moment. Their journey continues inward, uninterrupted. This difference is not an illusion. It is a consequence of how time itself behaves in strong curvature. Time near the black hole flows differently compared to time far away. And as the curvature increases, this difference becomes more extreme. This creates a layered reality, where different observers experience different versions of the same event, each consistent within their own path through spacetime. And this brings us back quietly to the idea we introduced earlier, that time is not universal, that it is shaped by gravity just as space is. Near a black hole, this shaping becomes so strong that time, from an outside perspective, appears to almost come to a halt at the boundary. And yet, within, it continues, guiding everything forward toward what lies deeper inside. As we continue, we will move further into this region, not to rush toward its center, but to understand what these paths truly become, how they converge, and what they reveal about the limits of our current understanding. Because within this extreme curvature lies not just a fascinating phenomenon, but a boundary of knowledge itself, where our descriptions begin to strain and deeper questions begin to emerge. As we move further inward, past the quiet threshold of the event horizon, the nature of spacetime begins to reveal something even more unsettling, yet strangely elegant. The idea that all paths lead inward is not just a poetic description. It is a literal feature of the geometry itself. Outside a black hole, you can choose your direction. You can move left or right, forward or backward, upward or downward. But inside this region, those choices begin to disappear. Not because you are restricted by a force, but because the structure of spacetime no longer supports those directions in the way you expect. To understand this, we can return to something familiar. In ordinary life, time has a direction. No matter what you do, you move forward through time. You cannot choose to remain still in time or reverse your direction. Your future is unavoidable. Now imagine that inside a black hole, this same kind of inevitability applies not to time, but to space. Moving toward the center becomes as unavoidable as moving into the future. It is not a place you are heading toward by choice. It is a direction that all possible paths lead to. And this is why the idea of escaping becomes meaningless. It is not that escape is difficult. It is that there is no path that leads outward. The geometry simply does not include it. This is one of the most profound consequences of curved spacetime taken to its extreme. It transforms what we think of as space into something that behaves more like time, where progression in a certain direction is inevitable. And yet, even here, the experience of falling remains strangely uneventful, at least at first. If the black hole is large enough, the curvature at the event horizon can be relatively gentle. You would not feel a sudden tearing or crushing as you cross it. There would be no visible boundary, no dramatic signal that you have passed a point of no return. The universe outside would still appear, though increasingly distorted, its light stretched and warped by the intense curvature. But as you continue inward, something begins to change. The curvature does not remain gentle. It increases rapidly, and the difference between one part of your body and another begins to matter. This difference is what we call tidal effects, but here they become far more intense than anything experienced near planets or stars. The part of you closer to the center experiences a slightly stronger curvature than the part farther away. At first, this difference is small, almost unnoticeable. But as you move deeper, it grows. Gradually, gently at first, then more strongly, your body begins to stretch along the direction of motion, while being compressed from the sides. This process has a name, one that sounds almost playful, but describes something very real. It is often called spaghettification, a stretching into a long, thin shape caused not by a pulling force, but by the variation in space-time curvature across your body. Again, it is not something grabbing you. It is the geometry acting differently at slightly different locations. And as that difference increases, the effect becomes unavoidable. But beyond this physical experience, there is something even deeper happening. As you move closer to the center, the curvature approaches a limit, a point where our current understanding begins to break down. This is what we call the singularity, though the word itself is more a placeholder than a true description. It represents a region where the equations of space-time predict infinite curvature, where distances shrink toward nothing, and where our concepts of space and time lose their usual meaning. But what this really means is not fully known. It is a sign that our theory, as powerful and accurate as it is, has reached its limits. It can guide us to the edge of this region, but not fully describe what lies within. And this is where a new layer of mystery emerges. Because everything we have described so far, every path, every curve, every distortion of time, is based on a theory that does not include the smallest scales of reality, the quantum world. At those scales, the smooth fabric of space-time may no longer exist as we imagine it. It may become something granular, something fluctuating, something far more complex than a continuous surface. And so, as we approach the center of a black hole, we are not just approaching a physical location. We are approaching a boundary between two ways of understanding the universe. One based on smooth geometry, and one based on quantum uncertainty. And at that boundary, our current knowledge begins to fade, leaving behind questions that remain open, waiting for deeper insight. As we continue, we will step back slightly from this extreme interior and look outward again to see how these intense curvatures affect not just what falls inward, but what escapes outward, in the form of ripples that travel across the universe itself. As we gently move away from the deep interior, where our understanding begins to fade, we can shift our attention outward again, to something equally remarkable, something that does not fall inward, but instead travels across the universe, carrying with it the signature of these extreme events. Because when space-time curves, it does not remain still. It can move, it can ripple, it can carry disturbances outward, much like the surface of a calm lake responds when something disturbs it. But here, the surface is not water. It is space-time itself. These ripples are known as gravitational waves, and they represent one of the most subtle and profound predictions of Einstein's vision. They are not waves moving through space. They are waves of space, a stretching and squeezing of the distances between points, propagating outward at the speed of light. And they are created when massive objects accelerate, especially when they move in complex, dynamic ways. Imagine two massive objects, such as dense remnants of stars, orbiting each other. As they circle, they are not simply moving through space-time. They are constantly reshaping it, creating changing patterns of curvature that cannot remain confined. These changes spread outward, like expanding rings, carrying energy away from the system. Over time, as energy is carried off by these waves, the objects spiral closer together, their motion becoming faster, tighter, more intense, until eventually they merge. And in that final moment, a powerful burst of gravitational waves is released, a sudden, sharp distortion that travels outward across the universe. But what makes these waves so extraordinary is not just their origin, but how subtle they are when they reach us. By the time a gravitational wave passes through Earth, the change it causes is incredibly small. Distances expand and contract by amounts far smaller than the size of an atom. And yet, with extraordinary precision, we have learned to detect them. Instruments designed for this purpose measure the length of paths using beams of light, watching for the tiniest shifts as space-time itself stretches and compresses. And when these signals are captured, they carry with them a story written not in light, but in geometry. From the pattern of a gravitational wave, scientists can determine the masses of the objects involved, how they moved, how far away the event occurred, and even details about the final moments before they merged. It is like listening to the universe through a new sense, one that does not rely on light, but on the vibrations of space-time itself. And this opens a completely new way of observing reality, because light can be blocked, absorbed, scattered by dust and gas. But gravitational waves pass through almost everything without interference. They carry information from regions that would otherwise remain hidden, such as the interiors of violent cosmic events or the earliest moments of the universe. In this sense, gravitational waves are not just a confirmation of our understanding. They are a new window, revealing aspects of the universe that were previously inaccessible. And yet, even here, the same principle holds. These waves are not forces traveling outward. They are changes in geometry, temporary distortions in the structure of space-time that move, propagate, and then fade, leaving the underlying fabric as it was before. And this reinforces the central idea that has been quietly guiding us from the beginning, that gravity is not something acting within space, but something that defines space, something that shapes how everything moves, how time flows, and even how information travels. But as we observe these waves, as we detect their patterns and decode their meaning, another question begins to emerge. If space-time can ripple, if it can carry energy, if it can behave in ways that resemble a medium, then could it have a deeper structure? Could these waves be hinting at something beneath the smooth surface we imagine? This question leads us toward one of the most profound mysteries in modern physics. Because while general relativity describes space-time as continuous, smooth, and infinitely divisible, quantum theory suggests that at the smallest scales, reality may be discrete, made of fundamental units. And these two views do not easily fit together. Gravitational waves, in a quiet way, sit at the intersection of these ideas. They are classical, continuous disturbances, yet they carry energy, something that in quantum theory is often associated with discrete packets. And this tension hints that our current picture, as elegant and successful as it is, may not be complete. As we continue, we will follow this thread further, moving beyond the dramatic events of black holes and merging stars into the broader structure of the universe itself, where gravity shapes not just motion, but the evolution of everything we can see, and much of what we cannot. As we widen our view beyond individual events like black hole mergers, something even more expansive begins to emerge, a realization that gravity is not only shaping isolated systems, but quietly sculpting the structure of the entire universe. Every galaxy, every cluster of galaxies, every vast filament stretching across cosmic distances is arranged according to the same principle we have been following all along, the curvature of spacetime guiding motion on the largest scales imaginable. And yet, when astronomers began carefully observing how galaxies move, something did not quite fit. The visible matter, the stars, gas, and dust, did not seem to provide enough curvature to explain the motions we see. Galaxies rotate too quickly at their edges. Clusters of galaxies hold together more tightly than expected. The paths being followed suggest a deeper curvature than what visible matter alone can create. And so a quiet mystery emerged. Something unseen appears to be shaping space-time, adding to its curvature, influencing motion without revealing itself through light. This unseen influence is what we call dark matter. It does not emit light, does not absorb it, does not interact in ways we can directly detect, and yet its presence is inferred through gravity, through the paths objects follow, through the geometry of spacetime itself. It is as if we are seeing the shape of something without ever seeing the thing itself. And this reinforces a profound idea. Gravity allows us to detect what is otherwise invisible. By observing motion, by studying paths, we can infer the presence of mass that cannot be seen. The universe, in this way, reveals itself indirectly through the geometry it creates. But the mystery deepens further. When scientists looked not just at galaxies, but at the expansion of the universe as a whole, they discovered something even more unexpected. The expansion is not slowing down, as one might expect if gravity were gradually pulling everything back together. Instead, it is accelerating. The universe is expanding faster over time, as if something is pushing it apart, or perhaps more accurately, as if space-time itself is evolving in a way that drives this expansion. This phenomenon is attributed to what we call dark energy, another unseen component, even more mysterious than dark matter. Unlike dark matter, which adds curvature that pulls things together, dark energy appears to influence the large-scale structure of spacetime in a way that causes it to expand more rapidly. It is not localized like matter. It seems to be a property of space itself, something inherent in the fabric, present everywhere, quietly influencing the evolution of the cosmos. And together, these two unseen components, dark matter and dark energy, dominate the universe. Everything we can see, every star, every planet, every galaxy, makes up only a small fraction of the total. The vast majority of the universe is something we do not fully understand, something that reveals itself only through gravity, through curvature, through the behavior of spacetime. This realization shifts our perspective once again. Gravity is not just a force or a curvature we experience locally. It is a tool, a way of uncovering the hidden structure of reality. It allows us to sense what cannot be seen, to infer what cannot be directly measured, to map the invisible through its influence on motion. And yet, even as we map this unseen structure, we are left with deeper questions. What is dark matter made of? Why does dark energy exist? Why does space-time behave in this way on the largest scales? These are not small questions. They are fundamental. They point to gaps in our understanding, places where our current theories describe what happens, but not why it happens. And this brings us to a quiet but important realization. The theory we have been using, the idea that gravity is the curvature of spacetime, is incredibly successful. It explains an enormous range of phenomena, from falling objects to black holes to the expansion of the universe. But it may not be the final story, because when we look at the smallest scales, where quantum effects dominate, this smooth picture of spacetime begins to conflict with the probabilistic, discrete nature of quantum theory. The two frameworks, each powerful in its own domain, do not easily combine. And somewhere, beneath everything we have explored, there must be a deeper layer, a more fundamental description that unites them. A theory that explains not just how spacetime curves, but what spacetime is and how it connects to the quantum world. This is one of the greatest open challenges in physics, and gravity, once thought to be simple, has become the key to unlocking it. As we move toward the final part of our journey, we will begin to bring these ideas together, not to resolve every mystery, but to reflect on what they mean and how they reshape our understanding of reality itself in ways that are both humbling and quietly beautiful. As we approach the final stretch of this part, the picture of gravity we have been slowly building begins to feel both clearer and more incomplete at the same time. Clearer because we now see how gravity shapes motion, bends light, stretches time, and even carries information through waves that ripple across the universe. But incomplete because every layer we uncover seems to reveal something deeper beneath it, something not yet fully understood. And perhaps nowhere is this tension more evident than at the boundary between the very large and the very small. Everything we have explored so far, from planets orbiting stars to black holes merging across cosmic distances, is described beautifully by the idea of smooth spacetime, continuously curved by mass and energy. But when we shift our attention to the smallest scales of reality, the world of quantum physics, this smoothness begins to dissolve. In the quantum realm, things are not continuous. They do not exist in precise, well-defined paths until they are observed. Instead, they exist in probabilities, in overlapping possibilities, in states that cannot be described as a single, definite outcome. And here a quiet conflict appears. The smooth geometry of spacetime, which guides motion so elegantly on large scales, does not easily accommodate this uncertainty. It assumes definite positions, definite paths, definite curvature. But quantum physics suggests that at the smallest scales, these certainties may not exist in the same way. And so we are left with two powerful descriptions of reality. One that explains the cosmos and one that explains the microscopic world. Both incredibly accurate, both deeply tested, and yet, when we try to bring them together, they do not fully agree. This is the problem of quantum gravity, one of the deepest open questions in science. What is gravity when viewed through the lens of quantum physics? Does space-time itself become uncertain, fluctuating, perhaps even discrete? Is there a smallest unit of space, a fundamental grain beyond which division is no longer possible? Some ideas suggest that space-time may not be a smooth fabric at all, but something more like a network, a structure made of tiny interconnected elements. Others suggest that space-time might not even be fundamental, that it could emerge from something deeper, something more abstract, perhaps related to information itself. These ideas are still developing, still uncertain, but they all point to the same conclusion: that our current understanding, as powerful as it is not the final layer. And gravity, which once seemed like the simplest of forces, has become the key to unlocking this deeper reality. Connects everything: the motion of galaxies, the bending of light, the flow of time, the structure of the universe, and possibly even the nature of space and time themselves. And as we reflect on this, something quiet and humbling begins to settle in: that what we experience as solid, stable, and obvious is actually the result of something far more subtle. You are not standing still. You are moving along a path in space-time. You are not being held down. You are being gently prevented from following your natural motion. The ground beneath you is not just supporting you. It is interrupting your fall. And time, which feels constant and steady, is quietly shifting depending on where you are, how fast you move, and how deeply you sit within the curvature of space-time. These are not abstract ideas. They are happening all the time, everywhere, woven into every moment of your existence. And yet, they are so subtle that we rarely notice them. Perhaps that is what makes gravity so unique. It is both the most familiar and the most mysterious aspect of reality. Always present, always shaping everything, and yet still not fully understood. And as we move into the final part of our journey, we will not try to resolve every mystery. Instead, we will allow these ideas to settle, to connect, to form a broader reflection on what it means to exist in a universe where space and time are not fixed, where motion is guided by invisible geometry, and where the deepest truths are often hidden beneath the most familiar experiences. As we enter the final part of this journey, the pace begins to soften, not because the ideas become simpler, but because they begin to settle into something broader, something more reflective. We have followed gravity from the familiar feeling of weight beneath our feet, through the quiet geometry of space-time, into the extreme curvature of black holes, and outward again into the vast structure of the universe itself. And now, what remains is not just explanation, but meaning. Because when you gather all of these pieces together, something profound begins to emerge. Gravity is not just a feature of the universe. It is a clue, a sign that reality is not built the way it appears on the surface. We began with a simple question: what if nothing is pulling you down? And along the way, that question transformed. It became something deeper. If nothing is pulling you, then what is guiding you? And the answer, as we have seen, is not a thing but a relationship. the relationship between mass, energy, space, and time, a relationship that shapes the paths everything follows. But even this answer is not complete, because it tells us how things behave, not what they are. It describes the rules, but not the origin of the rules themselves. And so, the mystery remains open, gently unresolved. What is space-time, really? Not just how it curves, but what it is made of, if it is made of anything at all. Is it continuous, smooth, and unbroken, as our current theory suggests? Or is it composed of something deeper, something discrete, something that only reveals itself at scales far beyond our current reach? And if it is something deeper, then gravity, as we understand it, may not be fundamental. It may be something that emerges from more basic processes, much like temperature emerges from the motion of particles, or like waves emerge from the collective behavior of water molecules. In this view, space-time itself might not be the foundation, but a kind of large-scale pattern, a structure that arises from something more subtle beneath it. This idea is still speculative, still being explored, but it offers a different way of thinking. Instead of asking how space-time curves, we might ask what gives rise to space-time in the first place. And gravity, rather than being a force or even a fundamental interaction, might be a consequence of deeper relationships, hidden beneath the surface of reality. This possibility does not weaken our understanding. It deepens it. It reminds us that every answer in science is part of a larger process, a step along a path that continues forward. And gravity, once thought to be simple, has become one of the most important guides along that path. It connects the largest scales of the universe with the smallest questions we can ask. It reveals the presence of unseen matter. It shapes the expansion of the cosmos. It challenges our assumptions about time, motion, and even existence itself. And yet, despite all of this, it remains incomplete. Not broken, not incorrect, but unfinished. And there is something quietly beautiful about that, because it means the universe is still open, still offering mysteries, still inviting exploration. As we continue, we will not try to solve these mysteries all at once. Instead, we will allow them to rest gently in the background as we reflect on what they imply. Not just about the universe, but about our place within it. Because in understanding gravity, even partially, we begin to understand something about ourselves. About how we move, how we experience time, and how deeply connected we are to the structure of the cosmos. As these ideas begin to settle, there is a quiet shift that happens not just in how we understand the universe, but in how we experience something as simple as being here, right now. Because if gravity is not a force pulling you down, but a result of the shape of space-time guiding your motion, then even this moment, sitting or lying still, becomes something different. You are not at rest. You are being gently held away from your natural path. The ground beneath you is not just supporting you. It is preventing you from following the curve that space-time has already laid out. And that curve is always there, silent, invisible, waiting. This realization is subtle, but once it takes hold, it begins to change how everything feels. Stillness is no longer the default state. It is something maintained, something created by resistance. And motion, especially the kind we call falling, becomes something natural, something effortless, something closer to the true behavior of objects in the universe. In a way, this means that the moments when you are not touching anything, when you are in freefall even briefly, are the moments when you are most aligned with the structure of reality. It is a strange thought that drifting, not standing, is the natural state. And yet, it fits perfectly with everything we have explored. But beyond this personal perspective, there is a broader implication, one that reaches into how we think about reality itself. Because if space-time is not a fixed stage, but something that responds, something that evolves, then the universe is not a static container filled with objects. It is a dynamic system where everything influences everything else through the geometry they collectively create. There is no true separation between objects and the space they occupy. They are part of the same structure, part of the same unfolding pattern. And this leads to a deeper philosophical idea, one that has quietly emerged from the physics without being forced. That the universe is not something that exists independently of its contents. It is defined by them, by their relationships, their interactions, their presence. Space is not empty. Time is not separate. They are aspects of a single, interconnected whole. And this idea challenges something very old, something deeply rooted in how we think. The idea that there is a background, a stage, and then things happening on that stage. Instead, there is only the process itself, the relationships themselves, the curvature, the motion, the unfolding, and you are part of that process, not separate from it, not observing from the outside, but participating in it with every moment that passes. Even your perception of time, the steady flow from past to future, is shaped by this structure. It is not universal. It is local, tied to your path through space-time, influenced by where you are and how you move. This means that reality, as you experience it, is deeply personal, not in a subjective sense, but in a physical one. Your timeline is your own, shaped by your journey through the universe. And yet, it connects seamlessly with the timelines of everything else, forming a coherent, shared reality that we can observe and understand. This balance between individuality and unity is one of the most elegant aspects of space-time. It allows for different perspectives, different experiences of time and motion, while still maintaining a consistent structure that binds everything together. And gravity is at the center of this balance. It is the mechanism through which this structure is expressed. The way the universe communicates its geometry to everything within it. But even as we begin to appreciate this, there is still something unresolved, something that remains just out of reach. Because while we can describe this structure, measure its effects, and predict its behavior with incredible accuracy, we still do not know why it exists in this form. Why does space-time have these properties? Why does it curve in response to mass and energy? Why does it behave according to these particular rules and not others? These questions do not yet have clear answers, and perhaps they point to something deeper still, something beyond our current frameworks. A layer of reality where the concepts of space and time themselves are no longer fundamental, but emerge from something more basic, something we have not yet fully grasped. As we continue, we will not rush to answer these questions. Instead, we will let them remain, gently present, as we move toward a quieter reflection, not on what we know, but on what it means that we do not yet know everything, and how that uncertainty is not a flaw, but a doorway. As we continue drifting through these ideas, something quiet begins to settle into place, not as a final answer, but as a way of seeing. A way of holding the mystery without needing to resolve it completely. Because perhaps the most important realization is not what gravity is, but how it changes the way we relate to reality itself. Earlier, we began with a simple assumption, something so familiar it almost felt unquestionable, that gravity pulls things down. And step by step, that idea softened, reshaped, until it revealed something far more subtle. That nothing is being pulled, that everything is following a path. And now, at this stage, that realization deepens even further. Because if everything follows paths through spacetime, and if spacetime itself is shaped by everything within it, then the universe is not built from separate pieces interacting across empty space. It is a continuous unfolding, where everything is connected through geometry, through relationship, through the quiet structure that underlies every moment. This means that distance, which we often think of as separation, is not quite what it seems. Two objects are not just far apart in space. They are connected through the curvature that spans between them, through the way spacetime is shaped by both. Their relationship is encoded in that geometry. And so, even across vast cosmic scales, there is a kind of continuity, a shared structure that links everything together. This idea becomes even more intriguing when we consider how information travels. Light, as we have seen, follows these curved paths, carrying with it images of distant stars, echoes of ancient events, traces of the past embedded in its journey. But even this light is not independent. Its path is shaped by the same curvature that governs everything else. So what we see when we look into the night sky is not just distant objects, but the result of a long journey through a changing geometry. We are seeing not just where things are, but how spacetime has guided their light toward us. In a way, every observation is a conversation with the structure of the universe. And this brings us to a deeper reflection, one that is less about physics and more about perspective. Because when we understand that space and time are not fixed, that motion is not forced, that everything is guided by invisible structure, it becomes harder to think of the universe as something rigid or mechanical. It begins to feel more fluid, more relational, more like a process than a collection of objects. And within that process, we are not observers standing apart. We are participants. Every movement we make, every moment we experience, is part of the same unfolding geometry. Even something as simple as breathing, as shifting your position slightly, is a change in your path through spacetime. It is a continuation of a trajectory that began long before you were aware of it, shaped by forces and structures extending far beyond your immediate surroundings. And yet, despite this vast interconnectedness, there is also something deeply personal about it. Your path is unique. Your experience of time, your position in space, your motion through the universe, all of it forms a perspective that no one else shares in exactly the same way. And still, all of these perspectives fit together seamlessly into a coherent whole. This balance between the individual and the universal is one of the quiet wonders revealed by gravity. It shows us that we are both small and deeply connected, both local and part of something vast. But even here, as we begin to feel this broader understanding, the mystery does not disappear. It remains gently present in the background, because we still do not know what spacetime truly is. We still do not know whether it is fundamental or emergent, whether it is continuous or discrete, whether it is the final layer or just one level in a deeper structure. And perhaps that is where the beauty lies, not in having all the answers, but in recognizing that the questions themselves lead us to a richer understanding. That uncertainty is not something to be avoided, but something to be explored, something that opens new paths rather than closing them. As we move toward the final segments of this journey, we will allow this perspective to guide us, not toward a conclusion, but toward a gentle resting point. A place where the mystery remains, but no longer feels distant or confusing, instead becoming something calm, something quietly present, like the curvature of space-time itself, always there, shaping everything, even when we are not aware of it. As we gently approach the final stretch of this journey, something begins to slow, not in the sense of stopping, but in the sense of settling. The ideas we have explored no longer feel like separate pieces, but like parts of a single, continuous picture, one that does not demand sharp edges or final answers, but instead invites a quieter kind of understanding. Gravity, which once seemed like a simple pull, has unfolded into something far more subtle, a shaping of reality itself, a quiet architecture that guides everything without ever being seen directly. And perhaps what is most striking is how easily this deeper truth hides beneath ordinary experience. You feel the ground beneath you, and it feels solid, stable, absolute. But now that feeling carries a different meaning. It is no longer just support. It is resistance, a gentle interruption of emotion that would otherwise continue freely. You are, in every moment, being held slightly away from your natural path, your geodesic through spacetime. And that path is not something you choose. It is something written into the structure of the universe, shaped by everything around you, from the earth beneath your feet to the distant galaxies whose gravity, however faint, still contributes to the overall curvature. This realization, when allowed to settle, begins to soften the boundary between what feels personal and what feels cosmic. Your experience is not isolated. It is part of a much larger pattern, one that extends far beyond your immediate surroundings. The same principles that guide your motion also guide the motion of planets, the bending of light, the merging of black holes, and the expansion of the universe itself. And yet, despite this vast scale, the experience remains intimate. It is happening here, now, in the simplest sensations of weight and stillness. There is something quietly humbling in that the same structure governing the largest events in the cosmos is also present in the smallest details of your everyday life. And still, even as this understanding deepens, the mystery does not disappear. Because knowing how something behaves is not the same as knowing why it exists in that form. We can describe spacetime, we can measure its curvature, we can predict how it will respond to mass and energy with astonishing precision. But we do not yet know why these rules are the ones that reality follows. Why space-time has the properties it does. Why it can bend, stretch, ripple, and evolve. And this leads us to a quiet but important acceptance that some of the deepest truths may not yet be fully accessible to us. Not because they are hidden, but because we are still in the process of discovering the language needed to describe them. Just as earlier generations could not have imagined spacetime as we understand it now, it is possible that our current view is only a step towards something more complete, something that will one day feel just as natural, just as obvious as this does now. And this is not a limitation. It is part of the process. Science is not a fixed collection of answers. It is a continuous unfolding, a gradual refinement of understanding, each layer revealing more detail, more connection, more depth. And gravity, perhaps more than any other concept, illustrates this beautifully. It began as a force, a simple explanation for falling objects. Then it became geometry, a curvature of spacetime. And now it stands at the edge of something even deeper, a gateway to questions about the nature of reality itself. What is space? What is time? Are they fundamental, or do they emerge from something more basic? These questions remain open, not as problems to be solved quickly, but as invitations to explore further. And as we sit with these questions, there is no need to rush toward answers. Instead, there is value in simply holding them, allowing them to exist alongside what we already understand. Because in doing so, we begin to appreciate not just the answers we have found, but the process of discovery itself. A process that mirrors the very structure we have been describing, paths unfolding through a landscape that is shaped by everything within it. And so, as we move into the final segment, we will allow the journey to slow even further, not to conclude, but to rest gently within the mystery, to reflect on what it means to live in a universe where even the most familiar experiences are shaped by something far deeper than they first appear. And now, as everything begins to quiet, we arrive not at an ending, but at a gentle, still point, where the ideas we have followed can rest, like distant stars settling into the night sky. There is no final answer waiting here, no single statement that resolves every question. Instead, there is something softer, a sense of perspective, a feeling of being part of something vast, structured, and quietly unfolding. Gravity, which once seemed like a simple pull beneath your feet, has revealed itself as something far more subtle. Not a force reaching out, but a shaping of reality itself. A quiet curvature that guides every motion, every path, every moment of time. And as you sit or lie here now, listening, that shaping is still present, still active, still guiding you in ways you do not feel directly. You are not fixed in place. You are moving, always moving, along a path written into space-time. The ground beneath you is gently interrupting that motion, holding you in a state that feels like rest, but is, in truth, a kind of resistance. And beyond this moment, beyond this room, beyond this planet, the same structure continues, extending outward through stars, galaxies, and the vast spaces between them. Everything is connected through this invisible geometry, not in a dramatic or forceful way, but in a quiet, consistent way. a shared structure that allows the universe to exist as a coherent whole. And within that whole, your existence is not separate. It is part of the same unfolding pattern. There is something calming in that idea, that you are not isolated, that even the smallest details of your experience are linked to the deepest structures of the cosmos. The rhythm of your breathing, the feeling of weight, the passage of time, all of it shaped by the same underlying reality that governs the motion of galaxies and the bending of light. And yet, even with all that we have explored, the mystery remains. We do not fully know what spacetime is. We do not know whether it is the final layer or something that emerges from deeper processes. We do not yet understand how it connects to the quantum world or what lies beneath its smooth surface. But perhaps that is not something to be resolved tonight. Perhaps it is something to rest within, because there is a certain peace in recognizing that the universe is not fully known, that there are still questions waiting, still paths to follow, still layers to uncover. It means that reality is not closed. It is open, evolving, inviting, and in that openness, there is room for wonder. So as your thoughts begin to slow, as the details soften and drift, you can let this idea remain gently in the background, that gravity is not holding you down, that you are part of a vast, curved structure, moving quietly through space-time, connected to everything around you. There is nothing you need to solve, nothing you need to figure out, just a quiet awareness that you are here, within this structure, carried along by it moment by moment. And as the universe continues its silent motion, stars orbiting, galaxies drifting, space-time curving and unfolding, you can simply rest, drifting just a little closer to stillness,